Welcome to Grade 2 Advanced Mathematics. In this video, we will learn how to solve physical problems involving velocity and how to find time, horizontal range, all those type of questions.
Welcome to Hasna Spot Math. Let's spark our math skills together.
Here we go. Usually what's the procedure? We start with acceleration, then we integrate to get velocity, then again we integrate to get the position, isn't it? Then we look at the situation and we fix what to be equal to 0. But as we handle multiple choice questions, let's approach the fastest method. The formula given v square is equal to va square plus 2as. Sometimes they'll give the formula directly. If not, let's memorize this one. Okay? And how to approach this question? Already the height is given as 30 feet. Formula is given. In case if not given, please memorize it. Acceleration is mentioned as negative 32. Since height is given, you should know height is nothing but your s, the displacement, which is negative 30. Why? Because it is dropping downward. Ground is down, right? So it is negative 30. Your s is negative 30. S is negative 30. A is already given as negative 32. Now what about your initial velocity? Initial velocity remains 0. So your VI remains 0. So basically your V is nothing but negative root 2as. Why negative? Because it's moving downward. VA square automatically got cancelled. Then squaring could be positive or negative. We pick negative because it is going downward. Now substitute the value of A, which is negative 32. Substitute the value of S, which is negative 30. And you will be getting the answer as negative 8 root 30, which is option B. Unit is very important. Here in this options all represent feet per second. In case if not, you should know the velocity unit is feet per second if your acceleration is feet per second square. Please try out this question. Same scenario as question number 1, but only thing it's given your S as negative 120. Your S value, you will take it as negative 120. Since it is feet, your acceleration is nothing but negative 32. And you are asked to find the velocity on impact, which will be negative root 2as. When you substitute the answer, you will receive negative 16 root 30, that is option D. This is a kind of understanding based question. In case if the height is multiplied by k, what factor does the impact speed increase? According to our formula, what we'll get, V is nothing but root 2as, right? So 2a no change. Your s, which is your height, gets multiplied by k. So let us visualize it as k, and your height is displacement. We'll take it as s. So now, yeah. So let's split it out. K is a constant. So let us split root k. And the rest is your actual velocity. So your speed is getting affected by root k value. So the answer is root k. Option C. That was the end of EOT 20. Now let's move with EOT 21. Here again we have used the idea of acceleration, velocity, position, integration type strategy, but now as you are using multiple choice, let's follow a formula for time of flight. T is equal to 2 VI sine theta. Depending on theta, you will switch your calculator between radian and degree divided by G. Here the theta is given as 60 degree, so don't forget to fix your calculator angle mode degree. So pure substitution, you have 2 and your VI is given as 98. Sine function, theta is nothing but 60 degree divided by your G. It's given. If it's not given, you should know meter means 9.8, feet means 32. Here it is meter, so it is 9.8. Let's substitute this value and you get it as 17.32, which is nothing but 10 root 3 second. This is also of the same scenario. Depend on your unit, you will fix your G value as 9.8 or 32. Also, please fix your calculator looking at your theta, whether it is degree or radian. But this time they asked to find the horizontal range. Let's fix the formula for horizontal range now as you are using multiple choice. Earlier we used to follow x double prime, x prime, x, isn't it? But now let's switch to this formula. That's VI square sine 2 theta divided by G. When you switch to this particular formula, VI, it's already given, that is 98. Let's square it. Don't forget sine double theta. So sine 2 multiplied by 60 degree. This full thing is angle, okay? So accordingly you can use the brackets divided by, since it is meter per second, the G value will be 9.8 and you will get 848.70, which is nothing but 490 root 3 meter. That is option D. This is also to find time of flight, same as question number 1. Please try it out and check whether you get the right answer. Your answer will be option D, 40 divided by 9.8 second. This is an understanding level question. Your projectile is launched at 30 degree. Another one is launched at 60 degree but with the same speed. You are asked to compare their ranges. You should understand something. Whenever two projectiles are launched with the same vertical speed at angles, that gets added up to 90 degree. That is complementary angle. They will land at the exact same spot. That's why their horizontal ranges are equal. Look at for sine 2 theta. When you consider 30 degree, this is of 60 degree, it gets added up to total 90 degree, which is complementary angle, right? You can either use this idea to fix the answer, both have the same range, or you can try it out. The difference happening only at the sine value, isn't it? So sine 2 times 30. The value will be approximately 0.866. You will get exactly the same value when you try for 60 as well. Sine 2 times 60. It will be of the same answer. With this also you can fix. It is option B. Both have the same range. This question is an extended version of the previous one. They asked to compare the horizontal range. When we look at the angle 30 degree and 60 degree, we know it is not option A, also not option B. It is exactly same horizontal range, but what? It is differing just by the value. For that, you are supposed to find the horizontal range. R is equal to 40, which is your initial speed, sine. Either you can try with 2 times 60 or 2 times 30. Anything is okay because both are going to be the same. So let me proceed with 2 times 30. Make sure your calculator is in which mode? Exactly, degree mode. Divided by 9.8. And it is 141.4 meter. That's the reason we fix option C. This is exactly as question number 1. T is equal to 2 VI sine theta divided by G. You will apply this formula. Substitute the values of VI as 40, theta as 60 degree and G as 9.8, and you receive the value as 7.07 second. That's option D. In this particular scenario, to find the parametric equation x and y, first let us look at the unit. Sometimes they'll give only mile per hour. You should be knowing how we get in feet per second. How multiply the mile per hour value 120 by 5280 divided by 3600. At that time you will get it in feet per second, that is 176. Okay, so your VI is 176. Look for your VI 176. In that case you will cross out option D. Option D is not the right answer. Now coming to the angle. It is below. When it is below, you should know it is negative. Your theta is negative 6 degree. In that case, you will cancel option A. So it's between option B and option C. Now let's look for your y of t. Y of t, if you recall, your 32, your acceleration gets integrated minus 32t, isn't it? When you have y double prime, or you will be getting it as negative 32. That's your acceleration. So when you go for the velocity, it will get turned as negative 32t. Again, when you go for your position, you will become negative 32 t square over 2, isn't it? And negative 32 and 2 get cancelled, which is nothing but negative 16 t square. So let's look for negative 16 t square in your y. That time we will reveal it is not option B. So the correct answer is option C. Then as usual you have V sine theta t plus your initial height, which is already given as 10 feet. So we finalize the answer as option C. This is also an understanding based question. The fixed angle, okay? If a player keeps a serve angle fixed at the optimal downward trajectory. But what's happening? They keep increasing the initial launch speed, okay? Just visualize you are throwing a stone at the same downward angle but with more force. It doesn't suddenly drop sooner, but it reaches the target faster and goes further, isn't it? That's how the ball passes higher over the net, but it's more likely to land long. It will cross the feet line. That's why the option C is the right answer. To find the smallest angle below the horizontal, let's depend on this formula. Y is equal to negative gx square divided by 2 v naught square cos square theta plus x tan theta plus y naught. If you look at for the values, since we are handling the feet, your g is nothing but 32. So negative 32. X value, it is 39 feet away. So your x value is 39. Let's plug in these values for the variables. Divided by 2. V naught is mentioned as 176. So 176 square. Theta is what you're asked to find, isn't it? So let it be cos square theta. Make sure your calculator is in degree because you're looking for the degree. Plus, what is your x again? 39. Tan theta plus your y naught, it is of 10. It is mentioned in the previous half. Your y naught is the height they have mentioned there because these all questions are interlinked with the same scenario. So it is given as 10 over there. So when you substitute with your y value as 3 feet, which is given here, you will get your theta value as 9.01. You will get negative which represent below horizontal. So your answer is option B. Even though it's of the largest angle, the formula remains the same. This time your x value is 60, V is 176, your y naught will be of 10 only, and theta is missing, and your y is 0. Okay, the height doesn't have because it already lands it. So y remains 0. So it is nothing but 0 is equal to negative 32 by 2. Can I write directly negative 16? Okay. So negative 16 multiplied by 60 square divided by 176 square cos square theta plus 60 tan theta plus 10. So when you substitute, you will get your answer as negative 7.69 degree. That we can represent it as 7.69 degree below horizontal. So answer is option C. In this question, you are going to find the smallest initial speed. So speed is missing. So our y value will be of 3, which is given the height here as 3 feet net. So 3 is equal to negative 32 by 2, which is negative 16. and your x value, the same scenario. So your x remain as 39 square. You're supposed to find V naught, so let it be V naught square itself. Cos square, theta is given here. What is theta? Downward angle of 6 degree, which means -6, and it is degrees, so your calculator should be of degree mode, plus x tan theta, that is 39 tan -6 plus 10. At that time, you will identify your V naught as 92.1 feet per second. Here, the maximum, they have asked to find the maximum initial speed, and the ball does not fly past the 60 feet service line. Downward angle is also mentioned. Here y remains as 0, so y is equal to -16, and they have mentioned your x as 60, so let it be 60 square divided by, we are supposed to find the velocity, so let it be V naught square. Cos square, downward angle, they mentioned downward angle, so cos square -6 plus 60 tan -6 plus 10. If those who have confusion how you got plus 10, please read the main question in the first slide. You will understand the full scenario to have an idea on how you are getting 10. And you will identify your V naught as 125.6 feet per second. That is option A. That's the end of finding velocity, time of light, horizontal range. In short, how to solve the physical problems on projectiles. So practice makes you perfect. Keep practicing. Use all the shortcuts to arrive at the right answer. Enter your fields in the calculator accurately. So yeah, that's all. Wish you all the best and bye-bye.